literally just a linear equation problem. You substitute back in for n just like you would a function, okay? Think of the subscript as the input back in for n. That's all you have to think of it as, okay? So does that help, guys? Any questions about that? And I apologize for the sign error the first time, okay? And again, this is what we're eventually going to get to, but for right now, I'll just give you guys the answer, okay? We can do the same thing with the next example. So for the next one, we're saying that the answer to the recursive sequence is -1 to the n over n factorial. And this is what we're trying to make into something that's not recursive. Okay, so let's go ahead and do that. So the sequence we're given is b sub n is equal to -1 to the n divided by n fact. And the relation, this is the same exact thing you guys have on the paper, just so that way I have room for this. B sub k is equal to the opposite of b sub k minus 1 divided by k. So, again, just like a function, we're going to substitute k, and then we're going to substitute k minus 1. When I substitute k back in for n, this just becomes -1 to the k divided by k factorial. So that makes sense, guys? All we're doing, we're just substituting the k. Okay. On the right-hand side, this is the opposite of -1 to the k minus 1. So it's the opposite of -1 to the k minus 1 divided by k minus 1 fact divided by k. So once again, guys, all I did was I substituted k minus 1 back in for n, and then we have this denominator of k because that's what was given to us. Okay, so does everybody understand how I substituted there?
Shouldn't it be k factorial all the way at the denominator because it's n factorial, right?
Well, remember, okay, see how it's k minus 1? So I plugged k minus 1 right in here for n. So that's how I got k minus 1 factorial. See how it's k? I just dropped the k down.
Oh, so, okay, gotcha.
Okay? This k is independent of this sequence. Okay?
Gotcha.
It has to be there no matter what.
So if you carry the k minus 1 on the bottom problem, why was it k? Oh, never mind, I thought it was k plus 1. I think I just wrote it down wrong.
Okay, yeah. It's easy to do that, isn't it? Okay, I was a victim of that last time. Alright, other questions, guys?
So for everywhere where there's m, we're only using, so if there were any other m, we would always use k minus 1.
Yep.
Because that's where it's with the b.
Correct, right. This subscript is basically the input for your function or your sequence. Okay? Alright, other questions, guys? Alright, now we have to simplify this pretty obviously. So if you guys were to simplify, let's just take a look at the numerator. Okay? How would you guys simplify that if it simplifies at all? Any ideas?
Can you do -1 to the k times -1 to the 1, like split it up?
Oh, I see what you mean. So, like this negative right here, you could think of that as like -1 to the first power. And then since you have a -1 to the k minus 1, you could use your product rule to be able to add those together. So we would have, and this is the right-hand side, so this would be the same as -1 to the k minus 1 plus 1. Okay. Is that what you meant, Donnie? Just shake your head yes and say,
Yeah.
yeah. Because guys, this is just your -1. Okay, does that make sense to everybody, guys? That's just a -1, and then you're multiplying it by -1 to the k minus 1. So that just makes it -1 to the k minus 1 plus 1. There's one more -1 floating around out there. Okay. What about this best down here? So, Frank?
Just multiply it by the reciprocal.
Yeah, because if you multiply by the reciprocal of that, so this would be k minus 1 fact times the reciprocal of k, which is 1 over k. Okay, right, is that what you meant, sir?
Yes.
With that? Yeah, nice. Okay. And hopefully you guys are seeing what's going to happen with this, right? Because obviously in the numerator, this just becomes -1 to the k, because the exponents will cancel out and just leave you with k of those. And then we have k minus 1 fact times k. Well, guys, what do you know about k times k minus 1 fact?
K fact.
Yeah, that just becomes k factorial, right? So this is every term, or every factor up to k minus 1, and this is the k. So if we wrote it like this, k times k minus 1 fact that's really the same as just k factorial. And that indeed gives us what we're looking for, the b sub k. Okay, so it does work out nicely for this one. Okay, so just some algebra with this. Hopefully not too difficult for you guys. But does everybody see the trick here with the -1? That's really just -1 to the first, and then we just added that -1 and the +1 together. And then this trick right here where you have k minus 1 fact. Okay, so any questions, guys, I can answer about that? Okay, we can even do it if we have a couple iterations back, much like we did with our second example we worked today. So let's take a look at something like that. Bless you. So we have a really basic sequence, okay, which is just 2 plus n. And then we have a not so simple sequence of something we actually almost solved today, 2c sub k minus 1 minus c sub k minus 2. It looks close to what we solved, but it's not exactly. Okay, so we have our c sub n equals 2 plus n, and then we have c sub k equals 2 c sub k minus 1 minus c sub k minus 2. All right, so all we're going to do is we're just going to replace n with k minus 1. Okay, so this is going to be equal to 2 times the sequence when we plug in k minus 1. So that's going to be 2 plus k minus 1. Okay. So does that make sense, guys, as to what c sub k minus 1 looks like? Any questions about that? Okay. And then we have to do the exact same thing with c sub k minus 2. So that's going to be minus 2 plus n, but instead of n, we're going to plug in k minus 2. So, it's just a game of substitution, that's all it is. Okay, so, let me make sure you guys are all okay with that. And does anyone have any questions about how we substituted? Okay, so now guys, it's just a basic linear sort of a relationship. I think everybody's able to simplify this fairly nicely, so let's go ahead and simplify it. Okay. In the parentheses, 2 plus k minus 1 just becomes k plus 1. So I get 2 quantity k plus 1. Over here, the 2's cancel out, and that's just left with minus k. We can distribute. We get 2k plus 2 minus k, or in other words, that just becomes k plus 2, or 2 plus k. Okay. All right. And of course, we still have to substitute back in here, but that's just 2 plus k anyway. So it looks like it works out rather nicely. Okay. I think one of the most difficult steps is just the first step where you guys substitute. Okay? So just be careful when you're substituting. Okay? Make sure you use your parentheses when you're substituting. In fact, if you want to, you can think of the sequences just like they're functions to make it really easy on yourself, okay? Like what you guys remember in pre-calc when you're doing function composition, this is essentially what you're doing with this, and it's simplifying, okay? All right, questions I can answer about if I give you the sequence that satisfies a recurrence relation, how to verify it, okay? And like I said, that's pretty easy to do. The hard part is getting to this animal, okay, which we'll eventually do, maybe today, most likely next time. Okay, Don?
Can you tell me how you got the 2 in front of all the first parentheses?
Right here?
Just in case, is that from the,
Yeah, that 2 is from right here.
So anything other than the k plus, the k minus 1, you also put into the,
Right, so what I did was, this k minus 1, I just plugged it in for n.
yeah,
And I also brought the 2 over, so I have 2 plus, instead of n, k minus 1.
okay, so the 2 just follows it, like.
Yeah, we just drop it down, okay? Just like function composition, if you're plugging in a function. Okay? Other questions, guys? All right. Before we can start talking about how do we get to this answer, we have to talk about 2 very common types of sequences, arithmetic and geometric sequences, okay? Both of them are very easy to work with. Some of you guys, or most of you guys have probably worked with them already. All right? There's 2 different ways to write an arithmetic sequence, okay? You can either write an arithmetic sequence in the closed form or the explicit form, where we have this, okay? This is the nice form that we want. Or you could write it in the recursive form. to where you just keep going through and you keep adding a common difference each time, okay? Now, we know that recursive is bad and a closed form is good. Okay, so if we can get to a closed form, that's great, okay? But if not, then we have to rely on the recursive form, all right? The same thing for a geometric sequence, okay? Geometric sequence just means you keep multiplying a number to get to the next one.
Can not all recursive formulas be put into?
Correct. Okay, that's an excellent point. Not every recursive formula has a closed form, if you would.
What's an example of that?
Oh boy, I can come up with literally
that's fine.
yeah, there's many more. It's like, have you suffered through Calc 2 yet, Ryan?
I am suffering.
Okay, so you know that not every integral can be evaluated, right?
Correct.
Like I can make up 100 integrals off the top of my head. It's the same way with these, okay? So unfortunately, not every integral can be evaluated, just like these, okay? There's a lot of them that I can make up that don't have closed forms. All right, so by the way, arithmetic sequence, we just keep adding numbers to get to the next value, okay? So just an example of an arithmetic sequence, I'll just write one up really quickly. Example of arithmetic sequence might be 5, 9, 13, 17, 21, etc. Okay. In fact, I just happened to borrow that one for some reason down there. So, but guys, notice that each time you're increasing by 4. That's an arithmetic sequence where you have a common difference each time. Okay. A geometric sequence, you multiply by a common factor. Okay? It can either be written as recursive or as a closed form. Okay? Again, the closed form is the nice form, the recursive is not so nice. Like for instance, guys, a basic example of a geometric sequence might be something like 1, 3, 9, 27, 81, 243, etc. Okay? Notice that the common ratio, okay, or the common factor to which we multiply each time is by 3. Okay? So that's the difference between arithmetic and geometric. Arithmetic you add, geometric you multiply. Okay, in fact, that might be easier for you guys to remember. All right. So, one of the things I'm going to ask you guys to be able to do, both for homework and also on your final, is I'm going to give you guys a geometric sequence, okay, in the explicit form. What I want you guys to do is to write both the recursive and the closed formula for the sequence, okay? And then I want you guys to find the 10th term in the sequence, okay? And you can either use the recursive method or you can use the closed method, okay? We'll figure out which one's easier in a few moments, okay? So let's go ahead and get to it, okay? So, in fact, I'll leave this formula up here so we can see it. All right, let's go ahead and do recursive first, all right? The first thing we might need to know is we might need to know the common difference, okay? Guys, in this example, what's the common difference? 4, because each of the terms differs by 4, okay? And we might need to know what the initial value of this sequence might be, okay? So, because if you look at the closed form, we need to know an initial value, a sub 1. So guys, what's the initial value of this sequence?
1.
1, right? It's the first term, okay? So does everybody understand what the common difference is, and does everybody understand what the initial value is? Initial value is just the first term, and then difference is just your common difference.
So all the initial value starts at like a sub 1, not a sub 0?
It could start at a sub 0, we just have to do a change of base, if you
Okay.
would, okay? Like remember we did a change of variable earlier in the course? We could do a change of variable here if we wanted to. We're not going to, but we could. Okay. All right, so for the recursive formula, so for part A, I know that the next sequence is going to be equal to a sub n minus 1 plus d. Okay, so we're going to say that a sub n is equal to the previous term, a sub n minus 1, which we don't know what it is, plus the common difference, which in this case is 4. And what I could do is I could use that, and I could just go through and get to the next term, and the next term, and the next term, and the next term. Okay, does that make sense, guys? Any questions? Not meant to be difficult. Oh, go ahead, Chris.
Why is it a sub 1 instead of a sub 0 for the initial term?
It's just the way that this is set up. Like I could make it a sub 0, but then I'd have to change this to n. Okay, so just the way that the formula is written, and quite honestly, I like the other way better, but this is the way the textbook presented it, and because I like to stay consistent with the text, if anybody in here ever reads it, I just don't want to deviate from what's in there. Okay, that's the only reason. Okay. All right, for letter B, we're gonna go ahead and we're gonna get the closed form, okay? Or the, so we're gonna go ahead and just plug it right in here. So a sub n is gonna be equal to a sub 1, which we know to be 1, plus the common difference, which we said was 4, times n minus 1. And then from there, guys, we can distribute and collect. So it looks like that a really nice closed form for this would be a sub n is going to be equal to 4n minus 3. Distribute your 4 and then add 1. Does that make sense to everybody, guys? Not meant to be difficult, okay? I mean, this is basically like algebra level. This isn't even like pre-calculus level stuff, right? You just plug it into the formula, and there you go. Okay. All right. Now, for part C, it says to find the 10th term in the sequence. Okay. Now, there's two ways to do that. Okay. We could use either formula to be able to do it. Guys, which formula would you like to use
B.
for?
B.
The second one, right? Because it's just a direct input. It's like a function, if you will. Okay? So we could say that the 10th term in the sequence, which we'll call a sub 10, is going to be equal to 4 times 10 minus 3, or in other words, 37. Okay? Just to illustrate, okay, we could go ahead and use Excel and show that the 10th term of the sequence recursively is going to be 37. Okay, so let me just show you guys. So this is 1, that's going to be equal to a sub 1 plus, what was it, 4, I think? And then we can just keep dragging it if we wanted to. Okay, and you'll notice that, hey, the 10th term is 37. Okay, so you could do it recursively. Let me make this a little bit bigger so you guys can see it. All right. That's not a decimal